And there comes a numerical question which says, given the standard electrode potential of potassium ions to potassium is minus 2.93 volts. Physically try to interpret it. What does it mean? It means that it is negative. That means it is not favorable, which means that potassium ions have absolutely no tendency to come back to potassium. Silver ions to silver is plus 0.8 volts. Mercury to mercury is 0.79 volts. And magnesium ions to magnesium is minus 2.37 volts. Please note, a lot of minus values. Cr3 plus to metal chromium is minus 0.74 volts. Okay. Arrange these metals in their increasing order of reducing power. Reducing power, what does this mean? That means metals are reducing others. And what is reduction? Gain of electrons. Reducing power is if somebody gives you electrons so that you are reduced. If they can reduce others, then they themselves are called reducing agents. If they teach others, they are called teachers. If they reduce others, they are called reducing agents, right? So, in this case, we are not concerned with metal ions, but rather we are concerned with metals. If I have this reaction, K giving you K plus plus electron, since this electron is given to somebody else, potassium is acting as the reducing agent, and for this E naught value, what would be the E naught value? Let's say this is minus, no, since it is the opposite, it is now plus 2.93 volts. Why you made it plus? This is reduction. Potassium ions to potassium. And standard reduction potential, see, standard electrode potential is usually SRP, it is reduction potential. And the way it is written also indicates reduction. Why? Potassium ions to potassium is minus 2.93, I reverse it. If I reverse it, I get plus 2.93 and of course the opposite reaction, right? Right. Then if we have magnesium going to magnesium ions plus 2 electrons, E naught is plus 2.37 volts. So, potassium loves undergoing oxidation, it absolutely adores giving away electrons and it is very positive about it. Magnesium also loves it, but not as much. So, magnesium is not that good a reducing agent as compared to potassium, but both of them indeed are excellent reducing agents, as we just saw in the electrochemical series also some time back. Now, what about others? Well, let me pick chromium. Chromium metal, if it forms chromium plus 3 electrons, this E naught looks like plus 0.74 volts, which at least, although it is much lesser than other ones, but it's positive. If you look at the other ones, if you have mercury and silver, more or less very close, going to mercuric plus 2 electrons, Ag plus 2 electrons, you would find their E naughts as minus 0.79, oh ugly, and minus 0.8, more ugly. Very close, but still. So my dears, this is the increasing order of reducing power. Most powerful is potassium, less than that is magnesium, then chromium, then mercury, then silver. This is increasing order of reducing power. Done? Done.